Good day, friends. You are welcome to your favorite learning channel, that is Royal Learning Channel. Today we are going to discuss about another very important topic in chemistry called stoichiometry. Stoichiometry. Then the stoichiometry is derived from two Greek words. Stoichiometry is derived from two Greek words. The stoichio is derived from stoichion. Stoichion. Then stoichion means atom. Stoichio means atom. While the metry is derived from metron. Metron. Then metron means what? Measurement. Metron means measurement. So which means that we can define stoichiometry as measurements of what? Of atom, or we say measurements of what? Measurements of elements. So I will define stoichiometry as the use of chemical reaction to calculate the amount, which is also known as the number of mole, the mass of a substance, the number of particle, the number of atom, the number of molecule of reactants and products in a chemical reaction. The use of chemical reaction to calculate the amount, the number of atoms, ions, molecule of reactants and products in a chemical reaction. I can also define it as quantitative study of reactants and products. Quantitative study of reactants and products in a chemical reaction. Then I can also define it as the use of balanced chemical equation. The use of balanced chemical equation to calculate the amount, the number of atoms, ions, molecule of or mass of what? Of reactants and products in a chemical reaction. So one thing that is very important in what? In stoichiometry is the use of balanced chemical equation. The use of balanced chemical equation, because before you can solve question on stoichiometry, you must be able to balance what? A chemical reaction. Then you must be able to derive your chemical reaction and what? And balance that chemical reaction. So as a science student, you are expected to know how to balance what? How to balance a chemical reaction and how to derive what? A chemical reaction and balance the chemical equation. So in today's topic, I'm going to give you tips. I'm going to give you tips on how to solve questions on what? On stoichiometry. I'll give you tips on how to solve questions on stoichiometry. And all questions that we are going to solve today, we start from scratch. We start from scratch. What do I mean by starting from scratch? What do I mean by starting from scratch? That is, we are going to form our chemical reaction together here today. Then we are going to balance our chemical equation, because your question may come with chemical equation and it may not. So you need to know how to write a chemical reaction and balance your chemical equation. Then you follow what? Steps. You follow necessary steps then to solve question on what? On stoichiometry. So what are the steps that you need to follow in solving questions on stoichiometry? What are the steps that you need to follow in solving questions on stoichiometry? The first step is to convert your questions in word problem to chemical reaction. You convert your questions in word problem to chemical reaction, because your question may come with what? With equation and it may not. So you convert your questions in word problem to chemical reaction. Number two, you balance your chemical equation. You balance your chemical equation. Then number three, you write out the substances that are involved or that will be involved in the calculation. You write out the substances that will be involved in the calculation. Those are the three steps, the first three steps that you need to take in what? In solving question on stoichiometry. In solving question on stoichiometry. Then your questions may come in form of mass relationship. Mass relationship. That is, when your first reactant particle, the substance, is in mass and the second substance is in mass, so you use what we call mass relationship. So the first one, we call it mass relationship. So mass relationship, that is, when the first substance is in gram and the second substance is also in what? Is in gas, is in ground. Then another one is mole mass. Mole mass relationship. So the mole mass relationship is the same thing as mass relationship. Why? Because the one mole of any substance is equal to the what? The molar mass of that substance. So it may come in form of mole mass. So mole mass and mass relationship are the same. Then another one is atom mass relationship. Atom mass relationship. Then the number of atom, one mole of any atom is equivalent to your what? Your Avogadro's constant. So when they are talking about atom, you are going to calculate the number of mole of that atom from the equation to your what? To your Avogadro's constant. You multiply the number of mole of that atom or the substance from the equation, you multiply by your what? By your Avogadro's constants. Why? Because one mole of any atom is equivalent to your what? Avogadro's constant, which is 6.023 times 10 raised to power 23. Then another one is volume. Let's call it mass volume. Mass volume relationship. Another one is mass volume relationship. That is, when your question is talking about the mass of a substance and the volume of what? Of a substance. So when your question is talking about the mass of a substance and the volume of a substance, you use what we call mass volume relationship. Then don't forget that the volume of any given gas at STP is equal to 22.4. Volume of any given gas at STP is equal to 22.4. So let's start with the following questions. Let's solve the following questions. Then don't forget that the first step to take in solving questions on stoichiometry is to convert our questions in word problem to chemical equation. Now let's see. Let's solve this first question. How many molecules of hydrogen gas will be produced? That is, hydrogen gas will be produced when 0.2 mole of aluminium reacts completely with what? Hydrochloric acid. So it shows that hydrogen gas will be gotten from what? Reaction between what? Aluminium and hydrochloric acid. So aluminium will react. Then the symbol for aluminium is what? Is Al. Aluminium will react with hydrochloric acid to get what? Hydrogen gas. That is hydrogen gas produced from reaction between aluminium and what? And hydrochloric acid. So what will be our product? Let's form our product. Then at this side we have aluminium. So this second reactant particle, let's break it down into hydrogen and chlorine because we have two atoms there. Then what is the charge on aluminium? The charge on aluminium is 3+. Why? Because aluminium is the number 13. So if I write the electronic configuration of aluminium in ratio form, it will be 2:8, then ratio 3. So the number of valence electron is what? Is 3. And those elements with what? With 3 valence electron are positively charged. So they will carry these 3 what? These 3 will not be their charge. That is +3. So the charge on aluminium is what? Is +3. Then hydrogen is the number 1. The charge on aluminium is what? Is on hydrogen is what? Is plus. Then why that of chlorine? Chlorine is the number 17. The first what? The first shell we carry 2, the second we carry 8, then the third we carry 7. Then those elements with 7 valence electron, they need 1 more electron. This one now, it needs one more electron to balance that outermost shell. So it shows that the charge on this what? On chlorine will be what? -1. But we don't always write it as -1, it's minus. So this minus means what? It means -1. Now to form our product, from the first reactant particle, you take positive, then you react with negative from the second reactant particle. Then if you look at aluminium is 3 plus, while chlorine is what? 3 minus. So the two charges must come together and neutralize each other to form what? A compound. So that is, this plus 3 must neutralize what? The charge on chlorine to form a compound. So -1, this minus means -1. So -1 will not neutralize what? 3 plus. So we multiply this one by 3. So by the time you multiply chlorine by 3, so we have 3 atoms of chlorine. So that is 3 minus, we cancel what? Plus 3. So plus 3 here. So this one is now -1 times 3 will give us -3. So two charges will cancel each other to give us. So our first product will now be AlCl3. AlCl, because the charges they've cancelled each other. Plus, now we have used aluminium, we have used chlorine, we have used aluminium, so we are left with what? With hydrogen. So hydrogen is what? Is the diatomic gas. So hydrogen will escape in form of gas. Hydrogen gas will be involved. So which means that our product, when aluminium reacts with hydrochloric acid, will be what? AlCl3 plus hydrogen gas. Now, we have changed this word problem to what? To a chemical reaction. That is the first step. We have changed the word problem to what? To a chemical reaction. Then the second step is to balance our chemical equation. The second step is to balance our chemical equation. Now let's balance our chemical equation. Then at this side we have one atom of aluminium from the reactant side. Then from the product side, this is product side, this is reactant side. So at the reactant side now, we count the number of each atom present at the reactant side. Then the number of atoms at the reactant side must equal to what? The number of atoms at the what? At the product side. Now we have one aluminium at the reactant side. So at the product side now we have one aluminium. So at this side we have 2, then we have 3 chlorine at this side, 3 atoms of chlorine. But we have 1 atom of what? Of chlorine at this side. So our equation is not balanced. Our equation with no balance. Then if I add 3 to this place, we are going to have odd number. We will not be able to balance the what? The number of hydrogen. Now let's add 2. Let's add 2. Then if you add 2 to this side, so it shows that we're having 2 atoms of aluminium. So we balance this side now. Then we have 6 atoms of what? Of chlorine. 6 atoms of chlorine. So you add 6 to this side. 6 atoms of chlorine. Then hydrogen now is 6 at this side. Then we have 2 atoms of hydrogen at this side. So we balance this side with what? With 3. We balance this side with 3. So therefore, our equation is what? Is balanced. Our equation is balanced. Then the next question now is to what? The next step is to write out the number of mole of substances that will be involved in the calculation. Write out the number of mole of substances that will be involved in the calculation. Now let's check from the question. How many molecules of hydrogen? So for hydrogen now, we need hydrogen. We need hydrogen gas. Then we are looking for the number of what? The number of molecule of hydrogen. So this means that hydrogen will be converted to molecule. How many molecules of hydrogen gas will be produced? How many molecules of hydrogen gas will be produced when is 0.2 mole of aluminium? So we also need what? Aluminium. So we need aluminiums. Then what are we talking about? Aluminium is the number of mole. So we need the number of mole for aluminium, while we need what? We need molecule for what? For hydrogen gas. So those two particles or the substances required from this chemical reaction are hydrogen gas and what? And aluminium. So we are going to write the number of mole of the substances involved in this what? That are required for the calculation. We are going to write them out. Now, from the equation, we need 2 moles. We have 2 moles of aluminium. So therefore, we say 2 moles of aluminium produced how many molecules of what? Of hydrogen gas. 3 molecules of hydrogen gas. According to our what? Our equation. The number of mole, the coefficient is the number of mole. The coefficient of aluminium here is 2. So now we go back to our question. How many molecules of hydrogen gas? So we are looking for the number of molecules of hydrogen gas. Then you come under hydrogen gas. You say X molecules. 3 molecules, sorry, because we are looking for the number of molecules there. So 3 molecules of hydrogen gas. Then how many molecules of hydrogen gas produced when is 0.2 mole of aluminium? So we have 0.2 moles. So you come under aluminium, you write 0.2 moles of aluminium. So now let's look at hydrogen. Aluminium is in mole. Then aluminium here is in mole. But at this side, they said 3 molecules. 3 molecules. Then 1 molecule of any what? Of any substance or any gas is equivalent to your Avogadro's number. 1 molecule of any substance is equivalent to your Avogadro's number. So it shows that I'm going to convert 3 molecules. They can give you in form of molecule, they can give you in form of atom, then they can give you in form of ion. So when they are talking about ion, atoms or molecule, so 1 molecule of us of any gas or any substance is equivalent to your Avogadro's number. Is equivalent to your Avogadro's number. So we have to convert these 3 molecules to what? To Avogadro's number. So therefore we say 2 moles of aluminium equal to 3 times 6.02 times 10 raised to power 23. So 1 mole of what? Of 1 molecule of any substance equal to 6.02 times 10 raised to power 23. Then we're having 3 molecules, so it will be 3 times 6.02 times 10 raised to power 23 of what? Of hydrogen. Of hydrogen. Then is 0.2 moles of aluminium will now be equal to what? X molecules. That is, we are looking for the number of molecules, the number of molecules of hydrogen that will be equivalent to 0.2 mole of aluminium. So the number of molecules of hydrogen gas that will be equivalent to 0.2 mole of what? Of aluminium. Then now you cross multiply. So we want to make X molecules the subjects of the formula. So make X molecule the subjects of the formula. That will be X molecules, or 2 times X molecules equal to 0.2 times 3 times 6.02 times 10 raised to power 23. 0.2 times 3 times 6.02 times 10 raised to power 23. Now we are looking for X molecules, so we divide both sides by 2. You divide this side by 2. So 2 we cancel 2. Therefore, X molecules will be equal to 1.8 times 10 raised to power 23. So by the time you use 2 to divide what you have at the numerator, that is what you have up, your answer will be 1.80 times 10 raised to power 23 molecules. 1.80 times 10 raised to power 23 molecules. That is how to solve the first question. Then let's move to number 2. Question 2. So the first step to take is to convert our questions in word problem to chemical reaction. So let's convert our question to chemical reaction. Calculate the mass of sodium hydroxide. So we are looking for the mass of sodium hydroxide produced by, that is, they produce sodium hydroxide by dissolving what? Sodium in cold water. So our reactant side now will be what? Sodium plus what? Plus cold water, because our product is what? Sodium hydroxide. That is, sodium hydroxide is being produced by dissolving what? Sodium in what? In cold water. Then what is the symbol? The chemical symbol for sodium is what? Is Na plus cold water. Then what will be our product? So let's form our product. Then what is the charge on sodium? Sodium is the number 11. When you write the electronic configuration of sodium in ratio form, that will be 2:8, then ratio 1. Now don't forget that those elements with valence electron of 1, 2, and 3 are positively charged. So the number of valence electron for sodium is 1. So therefore, the charge on sodium will be +1, which is the same thing as what? As plus. We don't always write it as +1. It is plus. So plus means +1. Then water molecule will decompose to hydrogen and hydroxyion. Hydrogen and hydroxyion. Then the charge on hydrogen is plus, because hydrogen is what? Is the number 1. So the number of electron what? The number of valence electron is 1. So it's +1. Then the charge on hydroxyion. The charge on hydroxyion is 1. Then I derive it from the charge on oxygen. I want to explain how I derive this charge on OH. The charge on oxygen is 2 minus, because oxygen is the number what? Number 8. Then the electronic configuration for oxygen will be 2:6. Now, like I said, that those elements with 5, 6, and 7 electrons are negatively charged. So you calculate the number of charge by the remaining number of electron to complete the octet structure. To complete that octet structure. So this one needs 2 to balance that 8. It needs 2. So the charge on oxygen is what? Is 2 minus. So if oxygen is -2 and the charge on hydrogen is +1, so -2 plus 1 will give us -1. That is how we derive this minus. So that is how we derive minus on OH. Now let's proceed. Now, what will be our product now? We take positive from the first reactant particle. We take positive from the first reactant particle and we react with negative. We take positive from here. We react with negative from the second reactant particle. So the positive here is +1. Don't forget that the charges must neutralize each other. The charge on this one is +1. Then the charge on this one is -1. So +1 will neutralize -1. So the two the two particles, the two ions will come together to give us NaOH. NaOH. So we have used sodium, we have used hydroxy ion. So we are left with what? With hydrogen. Then hydrogen is what? Is a diatomic gas. So it will what? It will be evolved in form of gas. Now we have formed our product. We have formed our product. So the next thing is to balance our chemical equation. So the next thing is to balance our chemical equation. So let's balance our chemical equation. Then at this side, we have one sodium, one at this side balanced, two hydrogens at this side, one here plus two, that is 3. So our equation is not balanced. Then let's add 2 to this side. So we have 2 sodium now, we have to balance this side with 2. Then 2 hydrogen here plus 2 hydrogen here, making 4 hydrogen. So we add 2 to this side. 2 times 2 will give us 4. So the number of hydrogen balance, then oxygen is 2. 2 times 1 oxygen, so oxygen is 2. Our equation is what? Is balanced. Our equation is balanced. Then the next thing now is to write out the number of mole of the substances that will be involved in the calculation. We write out the number of mole of the substances that will be involved in the calculation, because we cannot use what? All the substances here to solve the question. So let's come back to the question now. Calculate the mass of sodium hydroxide. Calculate the mass of sodium hydroxide. It shows that we need what? We are going to need sodium hydroxide, that is in form of mass, then slash by dissolving 2.3 grams of sodium. So 2.3 grams of sodium. So we also need what? Need sodium in grams. So that's 2.3 grams of sodium. So this question is mass relationship. The first substance is in form of mass. Then the second substance is in form of mass. So we call it mass relationship. Now let's write the number of mole of the two substances out from our equation. Now 2 sodium, we need sodium, so 2 moles of sodium. The coefficient here is what? Is 2. So which means that we are going to say 2 moles of sodium we produce, then we also need sodium hydroxide. We produce 2 moles, because the coefficient of sodium hydroxide is what? Is 2. 2 moles of sodium hydroxide. 2 moles of sodium hydroxide. Then don't forget that our question is mass. So we have to convert sodium to what? To mass in gram. We convert sodium hydroxide to what? To mass in gram. So the mass of sodium is 23. The atomic mass of sodium is 23. Then we calculate the atomic mass of sodium hydroxide, or the molar mass of sodium hydroxide. Let's first look for the molar mass of sodium hydroxide. The mass of sodium 23 plus the mass of oxygen. The atomic mass of oxygen is 16 plus the atomic mass of hydrogen is 1. So by the time you add everything together, it will give you 40 grams. 40 grams. So it shows that the mass of what? Of sodium hydroxide is what? Is equivalent to 40 grams. Then let's come back to this question now. 2 moles of sodium, 2 moles of Na will be equal to 2 times the mass of sodium, which is 23, equal to 46 gram. 46 gram. Now we now come back to our question, because our question has to do with what? Mass. This one is in gram, that is mass. Then the mass of this one too. Now we come back to the first step. So we have converted these 2 moles of sodium to 46 gram. Then we say 46 gram of sodium equal to, then we have converted sodium hydroxide to what? To mass in gram, because they said we should look for the mass of what? Of sodium hydroxide. So we have converted to what? 40 grams. Then we say 40. Then don't forget that we are having 2 moles of sodium hydroxide. We multiply by 2. So it will give us 80 grams. 80 grams. So therefore 80 grams of sodium hydroxide equal to 80 grams of sodium hydroxide. Then you go back to your question. Calculate the mass of sodium hydroxide. We are looking for the mass of sodium hydroxide. You come under sodium hydroxide, write x gram, because anything mass in what? Mass is in gram. So x gram of sodium hydroxide is equivalent to, by dissolving 2.3 gram of sodium. So they've given us another what? Mass of sodium, which is 2.3 gram. You come under sodium of what? Of sodium. Then therefore now you cross multiply to get the mass of sodium hydroxide. So it will give you 46 times x gram. 46 times x gram equal to 2.3 times 80. 2.3 times 80 gram. Then we are looking for s gram, so we divide both sides by what? Both sides by 46. Divide by 46. So 46 cancel 46. Then x gram of sodium hydroxide will be equivalent to what? So 2.3 times 80 divided by 46. 2.3 times 80 divided by 46 will give us 4 grams. 4 grams. 4 grams. So our answer for that is what? Is 4 grams. 4 grams. So let's move to question number 3. Now let's convert our questions in word problem to what? To chemical reaction. How many grams of carbon 4 oxide, that's CO2, how many grams of CO2 are produced? That is, CO2 is being produced from when 17.2 grams of oxygen reacts with methane. That is, reaction between methane and oxygen will produce what? CO2. So let's take reaction between methane. Methane is what? CH4. Then don't forget that methane is what? Is an organic compound. Is an organic compound. Is an alkane. That is the first member of what? Of alkane. So reaction between oxygen and methane. In organic chemistry, whenever any organic compound reacts with oxygen, your product will be carbon 4 oxide and water, CO2 and H2O. So this chemical reaction is called what? Combustion reaction. That it is common to all organic compound. It is common to all organic compound. So our product now is what? CO2 plus H2O. That is, carbon reacts with oxygen to give you CO2. Carbon and O2. Then hydrogen reacts with oxygen to give you H2O. That is, this one is reaction between carbon and oxygen, while this one is reaction between hydrogen and what? And oxygen. So the carbon is plus 4. Then oxygen is minus 2. 2 minus. So minus 2 times 2 will give us minus 4. Then plus 4. Plus 4 will neutralize minus 4 to give us CO2. Then hydrogen is plus. Oxygen is 2 minus. The charge on oxygen is 2 minus. So we have to multiply this one by 2 to give us plus 2. So plus 1 times 2 will give us plus 2. Plus 2 minus 2 will neutralize each other. Then therefore we have what? H2O. H2O. That is how to form our product. Then after that, the next stage is to balance our what? Our chemical equation. Let's balance our chemical equation. At this side, we have one carbon atom. One carbon atom. Then one carbon atom at this side. We have 4 atoms of hydrogen at this side. Then we have 2 here. So we have to put 2 here to balance our equation. 2 here. Then at the reactant side we have 2 atoms of oxygen. So at the product side we have 2 here. 2 here, that is 4. 2 oxygen here plus 2 oxygen here, that's 4. So then 2 here. So we have to balance this side with 2. So 2 times 2 will give us 4. So our equation is balanced. So what are those substances? What are the substances that will be involved in the calculation? So let's go back to our question now. How many grams of CO2? So it shows that we need what? We need CO2. We need carbon 4 oxide in gram. That is the mass. Then mass and what? How many grams of CO2 are required when 17.2 grams of oxygen gas, then followed by oxygen gas, 17.2 grams. So the carbon 4 oxide is what? Is in gram. That is the mass in gram. Then oxygen is what? Is in gram. So it shows that it is what? Mass relationship. Mass relationship. So the question is in form of mass relationship. So these are the 2 substances required. So we are going to write the number of mole of carbon 4 oxide and oxygen out of this chemical equation. Then how many moles of carbon 4 oxide do we have here? The coefficient here is 1. So therefore we are going to say 1 mole of CO2 produced how many moles of oxygen? How many moles of oxygen? From this equation we have 2 moles because the coefficient here is 2. So 2 moles of oxygen. Now, our carbon 4 oxide is in gram. We are looking for the mass of carbon 4 oxide in gram. Then oxygen also is what? Is in gram. So it shows that we have to convert our carbon 4 oxide to mass in gram. Then we convert your oxygen in mole to what? Mass in gram. So carbon 4 oxide now, what is the molar mass of CO2? The mass of carbon is 12 plus the mass of oxygen is 16. Then we have 2 times 2. We have 2 atoms of oxygen. That is 12 plus 32 will give us 44 grams. So the mass of carbon 4 oxide now is 44. Then we also have 2 atoms of oxygen. 2 atoms of oxygen. Then oxygen is 16 times 2. 16 times 2, that is what? 32. Then we have 2 atoms. So we multiply this 32 by 2. Since we have 2 atoms, so it will now be 2 times the molar mass of what? Of oxygen gas is now 32 times 32, which is equal to 64 grams. So 2 moles of what? 2 moles of oxygen gas is 64 grams. So let's go back to this first step now. Let's go back to the first step. Now, 1 mole of CO2 in gram is now 44. 1 mole of CO2 in gram, that is, we now say 44 grams of CO2 produced. Then 2 moles of oxygen, that's 2 times 32, which is equal to 64 grams. So 2 moles of oxygen is now what? 64 grams of oxygen. Now, they said how many grams of CO2? I'm looking for the what? The mass of CO2. So you come under CO2, you write X gram because you don't know now. X gram of CO2 equal to are produced when 17.2 grams of oxygen. 17.2 grams of oxygen. So come under oxygen, write 17.2 grams. So 17.2 grams of oxygen. Then we cross multiply. Cross multiply. So by the time you cross multiply, x gram times 64 will give us 64 times x gram equal to 44 times 17.2. 44 times 17.2. Then you divide both sides by what? By 64. Divide this side by 64. So therefore, our answer will be what? So by the time you 64, we cancel 64. Here we have what? X gram. X gram will now be equivalent to, so 44 times 17.2 times 64 will give us 11.83 gram. So our answer will be what? 11.83 gram of what? 11.83 grams of carbon 4 oxide. 11.83 gram of carbon 4 oxide will produce what? 17.2 grams of oxygen gas. Then the last question. The last question. So let's convert the last questions to the word problem to what? To chemical reaction. The word problem to chemical reaction. What is the mass of calcium dicarbide? Mass of calcium. What is calcium? Then dicarbide. Dicarbide is from carbon. So di means two. That's two what? Two atoms of carbon. Calcium, then dicarbide. Carbide is carbon. So mass of calcium dicarbide. So we need mass of calcium CaC2. Then needed. What is the mass of calcium dicarbide needed to produce 5.6 dm cube of ethyne? 5.6 dm cube of ethyne. Anything in dm cube is the volume. So the volume of what? Of ethyne. Ethyne. So we need ethyne. Then what is the chemical formula for ethyne? That's the second member of what? Of alkyne. The second member of alkyne. The general formula for alkyne is CnH2n minus 2. CnH2n minus 2. And ethyne is the second member. Ethyne is the second member. So my n will be 2. That's C times 2 will give me C2. 2 times 2, 4. 4 minus 2 will give me 2. So C2H2 is the formula for ethyne. Is the formula for ethyne. Then ethyne is given in form of what? In form of volume. 5.6 dm cube. 5.6 dm cube. Now this question is what? Is mass volume relationship. Mass volume relationship. So it shows that we are going to convert ethyne to what? The volume of what? Of gas at STP. So volume of any gas at STP is equal to what? 22.4 dm cube. So this one will be converted to what? Volume of gas at STP. Then this one will be converted to what? Mass of what? CaCO3. So let's look for the mass of CaC2, sorry. CaC2. The mass of calcium is what? Is 40. Plus mass of carbon is what? Is 12. So then we have 2 atoms of carbon, that's 12 times 2, which is equal to 40 plus 24. So 40 plus 24 will give us what? 64 grams. 64 grams. So the mass of calcium is what? Is 64 grams. Now, let's come back to our chemical reaction. Now, we have not written our chemical equation. What is the mass of calcium dicarbide? What is the mass of calcium dicarbide needed to produce 5.6 dm cube of ethane at STP when calcium dicarbide, that is when calcium dicarbide reacts with cold water? So that is, calcium dicarbide will react with cold water to form what? To form ethane. Calcium dicarbide will react with cold water to form ethane. So our reactant side, we are going to have calcium dicarbide plus cold water. Calcium dicarbide plus cold water. Now, this one will split to calcium and carbon. Then this one will decompose to hydrogen and oxygen. So calcium is 2, the charge on calcium is 2 plus. Then oxygen is 2 minus. This one is plus 4. Why this one is plus? So this one is plus. Then therefore calcium is what? Is plus 2. So positive and negative will give us CaO plus C will react with what? With H. That is, this C2 will react with what? H2. So we don't balance the organic chemistry the way we balance what? We balance inorganic reaction. So C2 plus H2 will give us C2H2. So C2H2 is our ethane. So we have formed our products. So the next step is to what? To balance our chemical reaction. Then how many calcium at this side? 1. We have 1 calcium atom at the product side. We have 2 carbon at the what? At the reactant side. We have 2 carbon atoms at the product side. Then we have 2 hydrogen at the reactant side, 2 hydrogen at the product side, 1 oxygen at the reactant side, 1 oxygen at the product side. Then our equation is what? Is balanced. Now let's bring out the number of mole of the what? Of the substances, of those substances that will be involved in the calculation. Then we need calcium, then we need ethane. We need calcium, we need ethane. So calcium, we need calcium, we need calcium dicarbide. We need calcium dicarbide, then we need ethane. So therefore, 1 mole of calcium dicarbide produce 1 mole of what? Of ethane. That's C2H2. Now, our calcium dicarbide, according to our question, it comes in form of mass. It comes in form of mass. Then we are going to convert this 1 mole to what? To the mass of calcium dicarbide. Then the molar mass of calcium dicarbide is 64. So therefore we are going to say 64 grams of calcium dicarbide equal to, then our ethane, it comes in form of what? Of volume in dm cube. Then volume of any gas at STP is equal to 22.4. So we are going to multiply this 1 mole by 22.4. So 1 times 22.4 will give us 22.4 dm cube of ethane. 22.4 dm cube of ethane. Then you go back to your question. Then according to our question, 5.6 dm cube of ethane is what? Is given. So 5.6 dm cube is given. So we come under ethane, we write 5.6 dm cube. So 5.6 dm cube of ethane. Then what is the mass of calcium dicarbide? according to this question, now what is the mass of calcium dicarbide? So you now write under calcium dicarbide, now you have x gram of calcium dicarbide. Then we cross multiply. So make x gram the subject of the formula. That will be 22.4 times x gram equal to 64 times 5.6. Then divide both sides by what? 22.4. 22.4 divided by 22.4. So 22.4 we cancel 22.4. Then x gram will now be equal to, so what will be our mass in gram? Our x gram. So 64 times 5.6 divided by 22.4 will give us 16 grams. So our final answer will be what? 16 grams. 16 grams. So it shows that 16 grams of calcium dicarbide will produce 5.6 dm cube of what? Of ethyne. 16 grams of calcium dicarbide will produce 5.6 dm cube of ethyne. So we've come to the end of today's class. Remember to subscribe to Royal Learning channel. Share this video with your friends and comment. See you in my next class. Bye.